Hi folks, Professor Amachi. Wanted to bring you through the 6.5.10 lab, and we're going to be exploring the evolution of password methods. Okay, so if you're ready, let's get started. All right, so welcome to 6.5.10 lab, and this lab is explore the evolution of password methods. So the first thing that we're going to do, obviously, is fire up the DevASC VM, and that's what we got going right out here. And then, how about we install packages and create a web service? So the folder that we're going to be under is under DevNet source and under the labs directory, and then under security right here. So the file that we're going to be editing out here is password evolution, and it's going to be in Python here. First things first, let's make sure that we have Pi one-time password. Make sure that we have this particular Python library installed. And it looks like we do, so we're going to be okay there. The other one is going to be Flask. Okay, and requirements already satisfied. I think we're good there. All right, so in this particular file here, we're going to be taking this code block that's in step 2. Why don't we take this out over here? Okay, we'll go ahead and paste this in here. So this is the Pi one-time password. We also have SQLite. It's the database for username and passwords. We also have hashlib and UUID. All right, let's create the local web service. So the local web service is going to be like this here. Okay, it's going to be the app route, and then we'll declare and define index right here. So index here is going to return a text string. Okay, we're also going to add this code block right here in step B. And we're going to do an app run here for a local host on port 5000. And check this out. So this is SSL context right here. And we're going to do ad hoc so that we're going to allow self-signed certificates. All right, so let's save this. Okay, we'll save and we're going to run. It's going to be no hang up, Python 3, and we're going to do password evolution.py, and we're going to tag on an ampersand right here, and the ampersand will keep the process running in the background. Okay, so check this out. A new file was created, the nohangup.out, and this is the output of nohangup. And so it looks like we do have the service running in the background. Okay, so we should be able to do a curl command out here. So we can curl -k HTTPS quad 0 over port 5000. Hey, cool. So we get our welcome message that was returned right there. All right, so before continuing here, let's terminate the script, and that's with the p kill. Okay, and password evolution. All right, part 4 here. We're going to explore Python code storing passwords in plain text. So when passwords were first used, they were simply stored in a database as plain text. When the user entered their credentials, the system looked up the password to see if it matched. System was very easy to implement, but as you can probably surmise, very insecure. So in this part, we're going to modify the password evolution Python file to allow it to store user identity in the test database. We're then going to create a user and perform an authentication against these credentials. And finally, we're going to examine the database to verify that they were stored in plain text. Okay, so step one here is we're going to remove the following lines. It's suggesting to remove the lines. I think we'll be good if we comment them out. Okay, so we comment that out. Step two here is to configure the server to store credentials. So we're going to copy this code block out to configure the server to store a username and password for a user in plain text. And using the HTTP post method, the code allows a user to create a new username and password that's going to be stored in our test SQL database. Later, when the user enters in a username and password, this code will return the message, sign up success. All right, so copy out this code block right here. How about we paste that in? And then we also need a verify plain up in here too. So let's take this code block out here. Okay, verify plain here. And then we are going to append the following code. And this code here is going to be used during each login to attempt to read the parameters from an HTTP request and verify the account. If the login is successful, the message login success will be returned. Otherwise, the user will see the message invalid username and password. Okay, so that's that portion right there. Let's see, run the server and test it. So add back the code that we deleted earlier. So that would be this right here. So let's take this. Save the file out here. Let's try to run this again. So no hang up, Python 3 password evolution. All right, here's our no hop out here. Okay, let's come out here to terminal. All right, then we entered in a curl command here. We created a username Alice with the password of my Alice password, and we sent this as an HTTP post to localhost over port 5000 on the sign up here. Okay, so once we did that, we got a sign up success right here. All right, so let's do the other one. I think the other one's going to be Bob. Okay, so copy that out there. Let's go ahead and paste this and then hit enter. Oh, awesome. We got our sign up success that's down here. Okay, and verify the users can log in now. Okay, so how about we do this. Login was successful. And then let's try the login for Bob. Okay, and login successful right here. So cool. How about we terminate the server here? That's the p-kill there. So we went ahead and we terminated that process. So I think we're good there. You may have noticed that SQLite created a test DB file that's right out here. So we can either cat it or we can use a text editor here. How about if we try to cat the file? Okay, and as you can see, we got a bunch of garbage in here. So how about open the DB browser for SQLite application? All right, that's gonna be out here then. So application all. all applications. Okay, then it's going to be DB browser. DB browser over here. All right, so how about we do file and we do open database here. Okay, and we'll navigate to find that test DB here. So then that's under labs, that's DevNet source, that's under security. Test DB, so how about we open that? Okay, and there's a table here called user plane. Okay, so user plane, how about we open that? Okay, so there's a structure. If we click on browse data here, we see Alice is right here, and there is the password for Alice. And for Bob, hey, here is the password. So cool. It's a pretty handy little tool here. Right, I have a feeling we're going to be coming back to this particular utility soon. All right, part 5 here. Instead of storing passwords in plain text, we can hash it when it is created. So when the password is hashed, it is converted into unreadable text. This prevents anyone from converting it back to its correct plain text version. Even if the database is stolen and cannot be used because the hash is not known. So we're now going to modify the password evolution file to create a web API that can accept a web request and save a new user's password in a hashed format. Here we go again. We're going to comment this out. And I have a feeling we're going to be adding that in a little bit later. So how about we comment that and then make some room for us here. So we're going to add the following code here to enable the server to hash the password using a SHA-256 hashing method. Notice that this code is similar to the code that we included previously. So this code allows a user to create a new username and password that will be stored again in this test user database. The difference is that the passwords will be stored as hash values instead of being plain text. This routine uses SHA-256 but does not salt the hash. We will see the implications of using a hash without salt when we view the test database file. All right, so let's add in this code block right here. Okay, that's going to be this here. Okay, and then the verify hash, that's going to be out this way. And then we're going to append this here. So it's login v2. Add this back in here. Okay, and we'll save here. And let's go ahead and run this again. So clear that out. All right, so we got the service running right there. Okay, so cool. Let's add in username Rick. Okay, sign up success. Cool. Okay, let's add in username here. Alan. Okay, cool. Sign up success. Okay, how about we also add in a username called Dave. Outstanding. Sign up success there. All right, so we're going to use curl commands here to verify the login of all 3 users here. Okay, login success here for Rick. Okay, we got a login. Okay, invalid username password. Yep, that's the wrong password. But let's type the right password in there. Okay, we got a login success. And try the one for Dave here. Okay, login success. I think we're good there. Okay, this confirms that the hash passwords are safely stored and the passwords of users are protected should they become compromised. So let's go ahead and stop here. Well, I think the easiest way is just to do a history and execute 134. Okay. So let's verify the contents of that test database. Okay, file, open. Hey, there it is here. Okay, so there's our tables here. We have now user hash. And then check this out. So if we browse data, we have the password hashed out here now. All right, cool. So then part 6 here is just the final script, the final program here that you can use to go ahead and verify yourself. All right, so there's the plain text table and the user hash table. All right, outstanding work, folks. Hope you enjoyed going through the lab. I certainly enjoyed going through it with you. Be sure to like and subscribe, and we will see you on the next.